Good morning to all. Today we will be discussing about lithography. Okay, so this is one of the technique that is utilized in the preparation of different integrated chips ICs. Okay, so you are familiar with many ICs. Okay, so in that process it is involved a patterning process and different kind of fabrication sides are involved. As you have studied in the last class about thin film preparation, so there are different coatings has been made, and during the process we need to pattern the transistor in different fashion. For example, if I give a MOSFET transistor, as you can see in the figure, okay. Yeah, so this is a MOSFET transistor. Okay, so this is a transistor design concept that is utilized in order to the preparation of a MOSFET in a industrial side. Okay, so here you can see different component of a MOSFET transistor. Okay, and you can see that there are we have a p-type substrate. Over the p-type substrate we will be coating different metal oxide size, and there are different step size region. You can see that in these regions we need to deposit different thin oxides as gate, and thin isolation oxides as will be there, and we need to create a gate contact, source contact, and drain contact. Okay, so which is actually made up of different metals. Okay, so we know even in a p-type substrate, in order to create a MOSFET transistor, there are many procedures are involved. And you can see that when you look at as a perspective of a person who is fabricating this MOSFET transistor, you can clearly understand that it involves different levels of coating and different levels of patterning that is involved in order to create a MOSFET transistor in an industrial basis. Okay, so it demands a kind of lithography process. We already said that lithography is one of the process which considered as a top-down approach in nano material preparation. Okay, where actually you can pattern a given material to create on your demand. Okay, okay, so the lithography is one of the tool to create the okay, so when you see the actual CMOS transistors that is made up on a wafer, like as you can see here, this is a transistor wafer which is made up on a CMOS transistor on a wafer. Okay, so when you see any construction of the integrated chips like ICs, you can see that we have a silicon wafer. On that we will be an oxide insulator, and we have a gate source here or a transistor you can see here, and we have a metal wiring on the top. So this is how the entire diamond crystal structure will look like. And also this transistor will be having a dimension less than 100 nanometer. That's a very important point. Okay, so when you see that the dimension also very small, and we need to work it on this very small dimension in order to create this gate. Okay, so this process of creating this transistor in a low dimension process in a IC chip making is a very key. So in that key process, lithography is the one of the process that is involved into the this kind of patterning and preparation of ICs. Okay, so there are many type of processes are there to prepare integrated chips. So integrated chips preparation, first of all we need to have a proper circuit designing process are involved. Okay, and of course there will be a mask design will be there in order to properly adjust arrange the each parts to be masked and wherever you want to coat. Okay, so is a bit tedious process, and it involves a lot of process like lithography, fabrication, and at least precision should be also involved in that process. So what we will be looking at this point is that we will be talking about lithography, and simply the lithography meaning is that you are putting a scratch or you are putting a pattern on a surface. Okay, and you are actually making the given film or given material, you are actually cracking down, so you are actually disturbing a bit. So you are firstly you are preparing a thin layer and you will be patterning it, and you will be depositing another film on the surface on demand. Okay, so that's how we do. So we'll just see so what are the different properties and different types of lithographies are available, and in order to prepare different semiconductors. So it is one of the important tool, as I already mentioned, to prepare the integrated chips. Okay, now we'll see what are the different types of chips are there in the market. Means lithographic methods are available in order to prepare this kind of chip. So the key are there are one is photon based, another one is electron based lithographic method, and we have a nano patterning by focused ion beam, and there is also a technique which is very convenient to any layman also, which is nano imprint lithography. Okay, so you would have already experienced these lithographic methods in a different fashion, not in a nano level, maybe in your normal understanding case as well. Okay, so we see the different type of lithographic method. So it involves the following. One is, as I mentioned, it is a photon based. Okay, so you can see a list of different type of lithographic techniques available. High resolution photon based lithography, where we will be utilizing deep UV for the lithographic purpose, and we will be having extreme UV uh, like X-ray lithography, X-ray optics, and mask will be there. So where we will be using photons, and also we have electron beam lithography. So by utilizing the electron optics, electron beam source and instrumentation will use for, and where we are dealing with the electron matter interaction, and of course the proximity, the nearest one, we will design the different type of patterns over there, and of course there will be a nano patterning by focused ion beams. It demands an ion source, ion optics instrumentation, and there will be we will be dealing with the ion matter interaction. Okay, which will be etching out the given material and will be creating the pattern that we demand. Okay, so this all process are actually we can control and we can do by on our demands. And the fourth type, which is called nano imprint lithography, NIL. Okay, there are two different types is there. One is thermal NIL and UV curable nano imprint lithography. Okay, so this is comparably a simple method that a layman can do nano imprint lithography, because we don't need a larger setup like I and UV source or ion source or electron source are not required for nano imprint lithography. You can do simply by taking any pattern and you can just place it on the thin films that you will be having, and you can heat it up. That is what the thermal nano imprint lithography is all about. Okay, so there you will be only utilizing the thermal part, and also you will be having a pattern that is already there in your hand. Okay, so sometimes you used to do, right, for like when you do tattoo and all. Okay, you just place the pattern and you will be just simply heating, or while you will be simply pressing, and the pattern will be converted to the body. Okay, so that's how a simple way of explaining the lithography, I would say. Okay, now we'll see each one how what we do different lithographic perspective. So you can see lithographic process when which we call it as AFM lithography. Okay, so AFM already we know that it is atomic force microscopy. It is one of the technique that you use to utilize in order to understand the morphology of a given material. Also can identify the particle size and the roughness of the given thin film. Okay, so we'll understand what is AFM later on in our characterization side of nanomaterials. Okay, so you can see that the tool you can actually utilize to scratch the given film. Here you can see that this is a film which is coated on a substrate, and this is an AFM image of that. And in that AFM image, you can see that there is a patterns of different dots. Okay, different dots you can see, and on the other side there is a scratch line you can see on the thin films as well. Okay, so what we have done is that simply scratching using AFM tip. Okay, AFM will be having a cantilever tip. Okay, so we will be actually, by utilizing that, we will be removing the material from the substrate by dipping deep trench like or dip or like scratches we will be keeping. So the advantage of this nano scratching for lithography will allow the precision of alignment you see using the AFM image. Okay, and the pattern whatever we wanted, we can actually in this process. The easiness is that you can see your film. Okay, you can see the film. By seeing the film, you can actually do wherever you want to the scratching, and also you can also pattern wherever you want to do, and the precision alignment of the patterns you can get it from this AFM lithography. Okay, so we don't have additional processing steps in this one because there is no etching of the substrate and all are not involved. Directly you can take the sample with the substrate and you can do the AFM imaging, and while do after AFM imaging you can do by using the there are different methods are there, contact mode and non-contact modes, different tapping modes are there. So in that we can use the tip will be contacting the surface and creating these different patterns. Okay, but the process when you talked about this AFM lithography, it is not a clean process because there will be many dusters will be there, and AFM tip cannot be used for a long time because it can break. Okay, by using this scratching process, the tip will be go damaged very early. Okay, so that's a one difficult task when you talk about lithography. But overall, it is the simplest, and where we are doing actually a mechanical lithography. You are like simply you are scratching like a pen on a paper. So that's a effect that you can see there. Okay, so it is one of the simplest process of lithography where you can do the patterning by simplest means. Okay, and the next one which we talk about is scanning probe lithography. Okay, is again a method that is we suggest said the AFM lithography general ആയിട്ടുള്ള ഒരു representation തന്നെയാണ് the scanning probe lithography. Spanning probe മൈക്രോസ്കോപ്പിൽ വരുന്ന one of the microscopic technique ആണ് basically AFM technique എന്ന് പറയുന്നത്. അപ്പോൾ ഞാൻ പറഞ്ഞു we are actually using a tip. So we are actually using a tip over there. So we will be doing the mechanical patterning like scratching, and which is also called nano indentation. Okay, and chemical and molecular patterning we can do by this lithographic method, and we will be applying the voltage. Okay, by field enhanced oxidation and electron exposure of resistor materials will be enhanced, and we can actually manipulate the atoms or molecule by using scanning tunneling microscopes and or nanostructures by atomic force microscopy. Okay, so as you can see in the figure, we will be having a tip, and the tip will be in contact with the surface. The surface, when you see the atomic force microscopy, you can see that there will be a different height dips will be there. When you see the closely see the surface on the atomic force microscopy, and you can see that the tip will moving on the surface by creating the scratch or patterns that we demand. Okay, so that's how the scanning probe lithography and the AFM lithography will working out. Okay, so this is the tip, we call it as AFM tip, and here we will be having a laser beam in order to get connected to the photo detector to get the AFM image in a proper manner. Okay, and this size we can actually adjust by this movement of the tip can be adjusted by the XY positioning by piezo sensor, and this the deflection by from the laser beam, as I said, we can collect in a photo detector, which later on produce a photo image. Okay, so that's how we will be getting the image corresponding to this one. So another type we call it as dip pen lithography. Okay, dip pen lithographic method. So in dip pen lithographic method also, it's actually you will be dipping like a, it's not a pen after all. Okay, so we are dealing with the nano dimension. So it is a micro contact printing and writing using a fountain pen. So we will be using a AFM tip here, which will be inked. So we will be keeping something with material to be deposited, and the material is adsorbed on the target. So we'll be getting the features of less than 50 nanometer. Okay, and like multiple lithographic methods will be doing to complete throughput direction. Here you can see that here we will be having a blue patterns, and these blue patterns over that, if you can use a AFM tip, and the AFM tip will be just introduce a water meniscus. Okay, this will be in contact with the film. So by you can simply, if you control, you can actually write different patterns, as you can see here. And also here you can see that another pattern that is made up of here, and there is a simple kind of scratches or writings like they are trying to write. So it's a kind of dip and lithography. Again we will be utilizing the AFM tip, and we will be putting some ink. Ink means any material you want to deposit over here. Okay, so that can be utilized in order to do that. Okay, so in that process the molecules will be transported to the substrate, and that you can see over here. Okay, so that is another type of lithographic method. So that is we just talked about. And now in the AFM lithography process, we can also do a technique, because in this process also, if you want to oxidize a given material in a specific region, okay, this dip pen method can be utilized for that, because you will be getting an oxide content or anode in that perspective when you take the hydrogen molecule, or sorry, water molecule in that perspective. So there will be oxidation will happen in that process. Okay, and the molecule get oxidized by using this means. Okay, so the AFM lithography will allow for the locally in a particular region, the electrochemical anodization will happen, and it will be getting oxidized. So in a specific region you want to do oxidation effect, so this can be used. AFM lithography can be ideally used for that purpose. Okay, because in other processes, we know that when you do oxidation, the entire surface will get oxidized. But here we can specifically on a specific region, we can look into region, the oxidation. Okay, now another type of lithography which I need to talk about is STM lithography, where STM means scanning, tunneling, microscopy. Okay, scanning, tunneling, microscopic method. Okay, so in this method, it is comparatively you can actually. Okay, so here we will be applying a voltage between the tip and the substrate. Okay, so it is possible to deposit or remove atoms or molecule by applying this voltage. So here, in order to drag the atom, we will be utilizing van der Waals force between the tip and the atom. Okay, so the advantage of using scanning tunneling microscopy is that you can actually take a single atom by interaction of electron to the atom, and you can take one atom from one position to another position by means of scanning tunneling microscopy. So it is actually a tool to utilize the manipulation of big molecules and individual atoms within a system. Okay, here you can see in this figure we have ions on a copper 11 എന്ന് പറയുന്ന സബ്സ്ട്രേറ്റിനോട് അയോൺ ആറ്റത്തിൽ നമ്മൾ പ്രോപ്പർ ആയിട്ട് അറേഞ്ച് ചെയ്തതായിട്ട് നമുക്ക് കാണാൻ സാധിക്കും. Okay, so this can be also used in order to manipulate. Okay, so it's a nano patterning technique which has high resolution in the order of 1 angstrom. That's why we can deal with atoms. Okay, and also this information storage devices, we can actually utilize this technique because you can 1 atom per bit എന്നുള്ള രീതിയിൽ you can actually store data over there. So in that we can actually collect atom, we can place in a proper manner, and each atom will be acting as a 1 bit case. So high storage density memory devices create we can actually utilize this techniques to pattern. So that's another important lithographic methods that is we can see in this case. And now the other type of lithographic method that is now we are going to talk is about nano imprint lithography. So the nano imprint lithography, it is basically the lithography I suggested, I already told that where we need a pattern maker or a mold. Okay, so here you can see as you can see in the figure, the lithography is by using molding and the material will be transferring here. So here we can there are two type of lithographics are there. One is thermal nano imprint lithography. Okay, so in that case we will be having a mold over here, and we mold means you can see this blue one. So you can see that in blue one there is a small patterned blue one is there, so which is having a sample on the substrate. So the red one is the sample and which is placed on a substrate. Okay, so when you heat up the polymer, so this mold is basically a polymer material. When you heat up, so the mold will be pressing, and while you press that, so it will be pressing and it will create a nano pattern. And now if you cool down and remove the mold, you can see that there is an alternate red will be there. So there will be a spacing. Initially it was a continuous layer. After placing the polymer and removing, you can see that it is a patterned red material on a substrate. You can see that. Okay, further if you want to do that, then we can actually make again if you proceed this one, you can further make it as the substrate also you can take a dip of it. Okay, it is depends upon the substrate thickness and all. Okay, and this is one of the mask that we will be utilizing, or the mold that is used in a technique that when you, there's a AFM image of that one, sorry, CM image of that one. Okay, so when you see this material, okay, the patterns on the resist, if you see, so it will be a pattern as you can see like this. So this is a technique nano imprint lithography, where if you have a mold, you can actually convert that into the corresponding. So this is one of the easiest method in order to transfer a given pattern to a material. Okay, so that's an important tool that normally anyone can do. Okay, and another type which we call it as nano imprint lithography. Okay, which will be where we will be utilizing the technique of UV. Okay, in order to do the same nano imprint lithography here. So here you can see here what we do here, that gold patterning by lift of an example as we have taken as an example. Here you can see that we will be having a substrate which is a gray in color, and over that we will be having a monomer, a chain of a small chain of polymer. Monomer will be placed on top, and we have a quartz mold here. Okay. Now if I put the quartz mold placing over here, okay, okay, and we will be creating a patterns in that case. So after creating the pattern, further you UV irradiate with UV, okay, then there will be a nano patterns will be creating, and you can remove the pattern afterwards, and after taking out the pattern you can see that there will be a residuum of H will be there, okay, and this H will be having a patterns over here, and now you can deposit the gold evaporation over there, and you can lift off the other materials like the monomer. You can actually lift off by taking the acetone. So by that, if you want to pattern gold like in this fashion, this is you can utilize by in this method. So here we have a liquid resist which is soft and deformable by any mold, and we have a hardened by UV curing, and the mold must be transparent. So such a mold like PDMS codes. Okay, no temperature is necessary in this process, and the process is very gentle process, and thermal expansion mismatch no longer an issue in this case, and many UV curable resistors are sensitive to oxygen exposure under inert conditions. Okay, so in that fashion you can see the different nano patterns you can actually made by UV technique. Okay, so we need a UV curable patterns, okay, to be created by nano imprint lithography here. Okay, so that's about UV lithography. Now we can see the nano patterning case, because you can know that nowadays if you have a pattern of your fingerprint, okay, you can actually take it off and can anyone can use, like you can see in the figure, uh, how do we get the pattern out of this one. Okay, okay. So lithography by molding material transferring by, this is a technique we call it as soft lithography. So it's actually the pattern duplication like we call it as. For a master mold is made by a lithographic technique, or rather like you can see that this is an image of our fingerprint result, that they are taking the pattern from the after an ink point. Okay, and polydimethyl siloxane is the most popular material for stamps. Okay, so we'll be using a silicon. Over that we'll be having a soft and flexible properties will be material will be utilizing. Okay, what can be cured by using stamp. Okay, and which is chemically inert. Okay, and good thermal stability is also there. Okay, so this is one of the processes called soft lithographic technique, like. Okay, so where you need to have a mask, and that mask will be easily converting to another one. Okay, so how its process is happening, you can see the this picture for a detail if you want to understand. Okay, so it is actually the process involves a lot of techniques. So a simple pattern can transfer via this method. Okay, so we have a mold. So this mold will be, over the mold you can actually keep a polymerize it, and you can keep, you will be getting a mold up in the terms of polymer. So you place it on the ink pad, and we'll be having an ink solution, and this ink solution will be keeping on substrate. And okay, so further if you keeping a chemical treatment over here, you can actually transfer the patterns over here. Okay, so that's how the soft lithographic patterns will be working out. Okay, So the requirement of, I already said that the lithographic technique is very important when you talk about the IC manufacturing case. Okay, so in the IC manufacturing cases, as you see, there are many properties can be infused, and many, like the lifespan of the mask. Okay, high fidelity, high throughput, high cost, so which will be utilized as a advantage for lithographic techniques. Okay, and fast throughput will be having a manageable cost, and the microprocessor required 39 plus mask levels, but here we can do it comparatively easier way. Okay, so the alignment between different layers can be easily controlled here. Okay, and the critical dimensions also can be controlled. So those all feasibilities are there while using a lithographic technique to different methods. And there is another lithographic method which we call it as optical lithographic technique. Okay, so in an optical lithographic technique, we will be having an optical mask over there. Okay, so we will be utilizing an optical mask in this situation to get a photolithographic technique. Okay, this is one of the important technique that is using in photolithography case. So here we will be having a photoresist. Okay, so over the photoresist we will be having a mask. Okay, sorry, this portion will be having this is a mask, and now we induce light. So the light will be coming only on this portion, right? This black portion only. The other portion, since we have a mask, there will be no light. So we will be getting the exactly pattern over that spot only. Okay, so here also you can see a similar picture here. So we will be having a mask. Okay, over this mask there is only one region through the light can come through. Okay, so when the light interact with that particular area, so the interaction will be resulting in a change. Okay, so the other region will be protected by using the mask. Okay, this is the one of the way you can actually utilize to prepare the patterning. Okay, so it's actually the blocking the radiation where we don't wanted the radiation, and the radiation will be absorbed by that particular area. Okay, so we need a opaque material at the desired wavelength to be utilized for this purpose, and the transmitted radiation where we actually demand we can actually control. So the mask normally we use it as quartz glass, which is a transparent, and the opaque situation we take it as chromium on the top. Okay, the formation of image with a UV or visible light in a photoresist. So there will be no limitation of the substrate. You can use glass, silicon, metal, plastic, anything over there. Okay, so this is a, I already said this is widely used lithography for different research and development case. Okay, especially for the micro fabrication of different structures and chip manufacturing process case. Okay, so this is a very simple process compared to any other process as well. Okay. Okay, there are three different configurations are there for the optical lithographic techniques, which are called mask contact with photoresist film. Okay, where P are representing the photoresist in this figure. Okay, so three optical lithographic configurations in order to focus on the different lines. Okay, so one is proximity aligner, contact aligner, and projection aligner. Okay, so in projection aligner is like a photographic imaging. So here it will be focusing on the gap between the mask of photoresist, and here it will be in contact with the mask resist film. Okay, so these are the two or three configuration way you can actually configure for the optical lithographic technique. Okay, so the photoresist, already we said the photoresist is a light sensitive material to form patterned coating on a surface. Okay, so it is a light sensitive ആയിട്ടുള്ള ഒരു മെറ്റീരിയൽ ആണ്. അപ്പോൾ എന്ത് ചെയ്യും, അത് ഫോട്ടോ അവിടെ ഇന്ററാക്ട് ചെയ്യുമ്പോൾ എന്താവും, സ്വാഭാവികമായിട്ടും ഇറ്റ് വിൽ ബി പാറ്റേൺസ് എന്ത് ചെയ്യും, ക്രിയേറ്റ് ചെയ്യും. സോ ദാറ്റ്സ് എ ഫോട്ടോ റെസിസ്റ്റർ എന്ന് പറയുന്നത് ഇറ്റ്സ് എ ലൈറ്റ് സെൻസിറ്റീവ് ആയിട്ടുള്ള ഒരു മെറ്റീരിയൽ ആണ്. ഓക്കെ, സോ ദാറ്റ്സ് അബൌട്ട് ലിത്തോഗ്രാഫിക് ടെക്നിക്. Okay, photoresist is a light sensitive material from background on a coating substrate, and which is classified into two positive and negative resistors. The positive are more soluble on exposure to radiation, which are called PMMA S180. Okay, as an example. Negative resistance it is less soluble under the exposure of radiation. Okay. Okay, so one of the limitation of this process is that we know that since the light is passing through a narrow object, right? So the patterns or mask should be in the order of the wavelength of the light. Then only you can observe the corresponding diffraction pattern. So that is actually leading to the proper masking process also. Okay, so the optical diffraction is one aspect that is we have to talk about in this perspective. The proximity, the length, the size of the slide, so the slit, and the intensity profile also should be important in aspect. So you cannot use a frontal diffraction patterns in this case. Rather, it is better to go for a frontal diffraction where will be the arrangements with distance. Okay, and it will be focused by utilizing a converging lens, right? So it is much more the better technique, because in proximity case, frontal case, the patterns and UV radiation and everything will be very adjacent to each other, right? It will be nearly placed. Okay, so that it is difficult to produce a proper intensity profile corresponding to the image. Okay, so that is one of the problem. So it is always better to W square by lambda, that is the corresponding condition where it should be less than equal to 1 to get a proper intensity profile for the optical lithographic technique. Okay, so that is the one only limit one can say that. Okay, so there will be two type of contact. We can say that one is contact and proximity photolithographic technique, where actually it will be in contact with the photoresist. The mask will be keeping in contact with the material. Okay, another case it is will be keeping with a larger distance. Okay, will be keeping in a bit larger distance. So that is we call it as contact and proximity photolithographic technique. Okay, contact and proximity lithographic technique. So here the mask is brought into the physical contact with the photoresist. Okay, and the resist image is 1:1, and there will be not limited by the diffraction pattern. So the damage of mask will be possible in this case as well. So we will be getting a high resolution if the with respect to the thickness, and you can see that thickness and resolution relation you can see here. Okay, and the proximity photolithography case, so there will be a small gap between the mask and the photoresist, and this will be a near field frontal diffraction effect will be there. Okay, and the resist thickness will be a key in the resolution as well here. The resolution is bit low compared to the contact case in this case. Okay, sorry, resolution is comparatively high the compared to other case. And in optical projection lithography technique, we already said that where we will be utilizing the Fraunhofer diffraction situation. So in order to the light will be coming from a far distance. In order to convert that light into exactly to the mask, we need a converging lens, and further we need a lens to on a screen to focus it up. Okay, So this process involves uh, a projection lithographic technique. We have a point source, collimating lens, and aperture, and a focusing lens that is focusing on the image plane. Then it will be the resolution will be 0.61 lambda by n sin theta, where n is the numerical aperture of the this particular mask. Okay, so it is similar like a photographic case. The resolution is limited by the far field diffractions. Okay, as we talked about, and it is very expensive for the case of semiconductor industry to prepare this one. So normally they use it, but highly expensive in terms to utilize this technique for a semiconductor situation. Okay, and also if you have a short wavelength of light, then if the high resolution can be achieved with a small numerical aperture if you use. Okay, so that's also we need to add in that perspective. And then if you want to deal with a even smaller wavelength, okay, even smaller wavelength of light if you want to utilize, you can also go for X-ray lithographic technique, where you will be again using a photon itself, but if you want to use a smaller wavelength of light and you need to get a resolution of light, the X-ray will be produced by synchrotron radiation, so which will be possessing high energy but low wavelength of rays. Okay, so if you want to utilize such kind of photolithographic technique, so then you can go for X-ray lithographic technique in order to pattern your given system, pattern material. Okay, so that is also there. So in X-ray lithographic technique, how it works, there also we need to have a frame mask should be there, and we will be patterning, and the X-ray will be interacting with the matter present over there, and correspondingly we will be getting an image as you can see over the here. Okay, so the glass frames will be there, the incident X-ray will be interacting with the photoresist, and while removing that there will be different patterns can be observed as you can see in this figure. So this is an XRL mask are composed within thin membrane, so which is either silicon, beryllium, silicon carbide as used as the mass, and also this will be utilized for high Z atoms like gold, tungsten പോലുള്ള ഹൈ എൻഡ് ആറ്റത്തിനാണ് നമ്മൾ നോർമലി എന്ത് ചെയ്യുക എക്സ്റേ ലിത്തോഗ്രാഫിക് ടൈം, കാരണം എക്സ്റേ ഷുഡ് ബി അബ്സോർബ്ഡ് ഓവർ ദർ ഇൻ ഓർഡർ ടു ഹാവ് എ റിയാക്ഷൻ റൈറ്റ്. സോ അത് ഹൈ എൻഡ് ആയിട്ടുള്ള ആറ്റത്തിലാണ് നമുക്ക് നോർമലി അത് യൂട്ടിലൈസ് ചെയ്യാം. സോ ദ ഇമ്പോർട്ടൻസ് ഇസ് ദാറ്റ് ഇറ്റ് ഹാസ് എ റെസൊല്യൂഷൻ ഡൗൺ 30 നാനോമീറ്റർ വരെയുള്ള പാർട്ടിക്കിൾസിന് പ്രോപ്പർ ആയിട്ട് എന്ത് ചെയ്യാൻ പറ്റും, ഇറ്റ് ക്യാൻ ആക്ച്വലി പ്രോബ് ത്രൂ ദിസ് ടെക്നിക്. So the XRL has both the advantage and disadvantage in that perspective as well. Okay, so when you talk about that, so we can also see there is a advantage, and also regarding the in terms of energy perspective we have a disadvantage as well. Okay, so which is very difficult to make the X-ray mask, and conventional lens cannot focus X-ray exactly into the material, and it's a bit expensive because it involves a synchrotron radiation sources are required to get a low wavelength X-rays. Okay, and but it has a good resolution and relatively fast and deep penetration to the resist and high aspect ratio, and here you can see different images which is patterned using XRL techniques. Okay, so that is also you can see in this picture. Okay, and also we can also utilize we suggested a case, right, template assisted assembly, so we just talked about earlier on in the last class. So this is also you can actually utilize as a technique to pattern a given system. Okay, so because here also we'll be using a nano pattern, okay, to create a nanoparticle assembly. So this is also a tool of lithography, one can also say in that point of view. Okay, so the defects will be fewer than 10 comparatively, and we will be getting exactly the same orientation of the mold. Okay, and the template based synthesis also we can take into the consideration in that point. Okay, so we can see that when you see by utilizing the lithographic technique, which is a top down approach, by using that approach one can actually make different patterns, which is actually very important in the perspective of semiconductor fabrication industry. Okay, and the IC fabrication case as well. So that's a very important case. So in that perspective, so this is a very interesting tool that can be utilized in many ways, like photon lithography, nano imprint lithography, okay, ion beam lithography, electron beam lithography. Now in many ways it is a very interesting tool to probe, and there are many works you can also see in the research point of view exclusively working on this aspect, especially nano indentation, as we suggested in the case of atomic force microscopy discussion. Nano indentation is a growing area where people are mechanically patterning on a system to get a different properties. The ideal case is that when you have a material or a continuous thin films ഉണ്ടെങ്കിൽ ആ continuous thin filmസിന് മുകളിൽ നമുക്ക് patterns generate ചെയ്യുകയാണെങ്കിൽ ആ പാറ്റേൺസിനുള്ളിൽ നമുക്ക് different other materials deposit ചെയ്യുകയാണെങ്കിൽ അതിനൊരു മൾട്ടി ഫങ്ഷണാലിറ്റി നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റും, ജനറേറ്റ് ചെയ്യാൻ പറ്റും. These two property will be combined, these two materials combined will give a new good different properties for a different aspect. Okay, so this multifunctionality and the incorporation of and the fabrication of different devices also a effective way of preparation is in lithography will be helping a lot in that point of view as well. So when you come to the nano level, you can see that there are plenty of rooms at the bottom. This is a statement, very famous statement by Feynman. He has said that there is a lot of possibility you can see when you reduce the size of a particle to the down the level of nanometer. So he has predicted the future of nanotechnology by taking that term, and there's a famous essay or the speech that is he has done in Caltech University. It's on, there is plenty of a room at the bottom, you can just type it on the Google, you can find a beautiful essay that he has explaining the scope of nanotechnology. Okay, so if you can, and he has mentioning one of the interesting thing is that if you can completely catch all the words of a dictionary in a tip of a pen. Okay, so that's how the possibility of nanotechnology has been explained by famous scientist Feynman. You can see his many books on this one, and if you are interested you can see 2-3 pages of speeches which is based on plenty of the room at the bottom that is available on the internet. Okay, so it's a very interesting note regarding the nanotechnology. So it was a prediction that has been fulfilling in the nowadays. Okay, so you can just look at that too. So with that, I'll be just winding up the session on lithographic techniques, which is also a top-down approach. Okay, and the limitation of the day approach also we have already mentioned on different lithographic techniques that also to be noted. Okay, thank you.